designs were also good. Let's go ahead and take a look at how to create your tables. Keep changing my mind, but we have lots of time left. Here's how. Can you see them? That's all you need to know. So just the same as when we're updating data, we only had the 3 specific keywords we could use. Insert, update, what's that third one? Delete, yep. For objects in the database, we only have 3 also. Create, alter, and drop. So if we drop our table, we delete all the rows, but we also delete the definition for the table too. So we don't want to do that unless we really want to. So for any kind of item within the database, we can use that same syntax. Create sequence, create function, create procedure, alter, and drop. I feel like this should have been way earlier in our course. But here are the rules for identifiers like names, table names, column names, things like that. The first character of an identifier must be a letter, an underscore, an @ sign, or a number sign. All characters after the first letter must be a letter as defined by the Unicode standard, a number, an @ sign, a $sign, a number sign, or an underscore. We can't use a reserved word, can't contain spaces or special characters. And of course, we can always delimit them by putting the square brackets around to make something into a valid identifier. So here's the create database syntax. You saw I did it just really quickly, create database, database name. And I mentioned that we might have to specify what disk space it should be associated with. So here's all we need to create a database. And then we want to create some tables. Now creating tables takes a little bit more because tables have columns. So here we would do create table and then our table name, and then within parentheses, a list of all our columns. So our columns, each column identifier is going to have the column name, a data type, and then maybe some attributes. Some attributes might be like null and not null, that it's a primary key, that it's unique. So we can actually specify that something has to be unique within the table without it being a primary key, and that'll cause an index to be built on that field to make sure that it's always a unique value. We could specify that something is an identity column, like our IDs. We could specify default values for a column, and we could specify sparse. I don't know what sparse means. So here's creating a table with 2 columns. Neither of our columns have any special attributes. Here's creating a table, invoices, where our invoice ID is a primary key and it's an identity column. Okay, go find out what's sparse mean.
Kindly dispersed or scattered.
No, you did great. Finally dispersed or scattered. So that's kind of the opposite of clustered. If something is clustered, we want to keep the data close to the index. So say we clustered you guys by last name. That would mean my seating chart, I would have you in order by last name. You would be clustered by your last name. If I want you to be sparse, that would mean that I'd want you to be as far apart from your last name as you could be, so that I could walk across the database in a more effective manner based on my data. Or we might not have it often. So if I look at this one and I see this sparse keyword on vendor address 2, that's also telling the database that column may not exist. It may be sparsely filled. Every once in a while, we'll have an address 2. Now, if we decide we want to create an index on a column, because we've decided we're going to use that foreign key a lot in queries, we can create an index. We can create a non-clustered index here. They do it on the vendor ID. That just means if I do a query based on vendor ID, the system is going to internally use that index to speed access of those vendor IDs. SQL Server automatically creates a clustered index for a table's primary key. Now this is cool. Do you want to try it, the snippet picker? This is one of those things that makes you wonder what people were thinking. Let's go find the snippet picker. Open SQL Server Management Studio. And open a new query. Now let's see if I can figure out how to use this snippet picker. Somewhere there's this command that says insert snippet. There it is. I right-clicked here in my new query window and I see insert snippet. Okay, now that I said insert snippet, I can find the database object that I want a snippet inserted for. So let's say table. And now it's creating this syntax for me. My table. And as soon as I type in my table name and press enter, it drops that whole syntax snippet into the Management Studio ready to update. So if I couldn't remember, how to do my column specifications, it gives you quite a bit of help there with that snippet tool. Now, a lot of times, even if you're a database administrator and you're the person that's responsible for doing this, it might be months between you creating tables. So it can be hard kind of to remember all of the syntax sometimes. So the snippet tool just does that, tries to help you. So let's say I wanted to add a stored procedure. Then I could say that I want to do a fancy template. And so it's going to give me all sorts of different options there and then dump out some syntax for me. So I'll get rid of that. But that's just the snippet tool. Now, one term that they have here is the transaction log file. And this is an important concept. We'll come back to it again. But if you go to the convenience store and you get gas, have you ever used your debit card? Have you ever used a debit card to get gas? So if you put your debit card in and then it comes back and it says it's okay, you can start pumping gas, and then something goes wrong, I don't know, it's hard to imagine what could happen. We do this all the time and nothing ever goes wrong, right? But something goes wrong. I don't know, that tornado on the other side of town knocks a pole down and you lose power or whatever. At that point now, do you want your debit card to be charged? It should be charged for the amount of gas you got, right? But how is it going to be handled? What are we going to do? Well, in some situations, a vendor might decide that if something like that were to happen, they just want to roll that transaction back. They just want to pretend it never happened. So they might lose the 3 or 4 gallons of gas that were in the process of being pumped. But in general, they might say, we want to roll that back. Well, then to them, from the beginning of the point where you put your debit card into the machine to the point where you are done and put the gas thing back on the pump, that's one transaction, right? That transaction has to be completed the whole way for everything to work properly. If anything were to go wrong at any point within that transaction, some sort of recovery action needs to occur. So that's what a transaction is an event that may update more than one table, that may span some time, that all has to occur properly for everything to be completed. If I go inside the convenience store and use my debit card, my transaction is much faster, right? Because it's just I swipe, it's done, everything's good. But if I get gas, it's kind of a long carried out one. So think about a transaction like that. In order to be able to roll that back, to make it look like that never happened in the database, we keep a transaction log file. And this log file on the server keeps track of every update that occurs, whether it's creating a new database entity, adding an element to a table, updating the data in a row. It's all in that log file. So we can use that log file to roll things back manually. The database will use it to roll things back automatically. We've got a chapter that talks about transactions. So we can look at all of the different transaction syntax when we get to it. Now, all the different indexes are very important to us too, because they help us get to our data in a much faster way. When we're creating tables, there are several things that we could add on a column as a constraint. So these items I could put on each column definition: not null, primary key, unique. Check limits the values for a column. So if I have an item column that I want to be limited to the numbers 1 to 10, I can put a check constraint on it. Our foreign key constraint says there is a relationship between these tables, and it has a references keyword to specify what table it references. Now, those were column level constraints. We can also have constraints at the table level. So I can say that this column is my primary key, or I can wait and at the table level say my primary key is these 3 columns. Let's create a table. We have this. Let's go to our database and create this table, invoice line items 1. Now make sure you're in your database. We're going to create a table here, invoice line items 1. I didn't use the snippet tool. I'm just going to put my columns in here. First, I have invoice ID. It's going to be an integer, and it has a rule that it cannot be null. After the specifications for this column, I'm going to have a comma. Invoice sequence is going to be a small int. And I'm just looking at what they have here. And we don't want it to be null either. Lastly, we're going to have an invoice line item amount. It's going to be money. And it's not going to be null either. Now I'm done with my columns, but I'm still putting a comma after this last column because I'm going to specify my table level constraints. My table level constraint is that the primary key is the invoice ID and the invoice sequence. Bless you. Now, this is exactly what you guys could do for that line item table where we need to combine multiple columns to make it into a unique key. We could say the primary key is our line item ID, our patient ID, and our bill ID, if that's how you have yours set up. So we can make this primary key be the multiple columns like that. Let's create a comment or two here. Create a table. Have a composite primary key. I'll say by using a table level constraint. Add more. Now we can run that.
What do you want to make the ID identity?
Do I?
So you want to specify that the ID is an identity?
They don't want to. Mm-mm. No. So we're just going to run it. Good question, though. We are not making that invoice ID an identity column. We just have this primary key. So that worked, but I know that when I come over here to my tables, since I didn't have it expanded already, it could show up. Yep, there it is, invoice line items 1. So my table is showing up. If I expand it, I should be able to see my columns. Oh, and look, we've got our primary key marker by both of those fields. That looks good. Okay, let's create a couple more. I'm going to create them in the same query window. This time, we want to create a table named invoices 1. And invoices 1 is going to have some more column level constraints than this last one we did. Let's call this invoice ID. Still an integer. And not null. But we also want to make it identity and primary key. So in this example, since the key is only our invoice ID, we can state it at a column level constraint. Now our invoice total is going to be money. I could type it, and it's not null. We want a check constraint for this. So I'm going to put it on the next line, and I'm going to go ahead and tab over so that it's obvious that it goes with this invoice total. And we're going to put a check constraint that says invoice total must be greater than or equal to 0. And now I'm finally ready for my comma, because that's the end of that column. Now we're also going to add in a payment total. And this one is going to be money, not null. And we want this one to again have a check constraint that it is greater than or equal to 0. We just don't want these to be negative. That's all we need for our invoices one table. Let's create a comment or two here. Oh, I do, thank you. That one. So we'll say create our invoices. They use column constraints. So notice in this one, we can set our primary key just right there on our invoice ID, where in our previous one, since we wanted that composite key, we had to set it at the table level. So let's try to create this table. I'm just going to select it and run. And then I'll refresh my tables. There's invoices 1. Now, if we look at it, we should see it's 3 columns. And our key should show that we have that primary key. We should have some constraints though, shouldn't we? Oh yeah, look. Now we have constraints. Yes, sir?
I think the error that says multiple null constraints were specified for column invoice ID table invoices 1, and second one that says invalid column name invoice.
There must be something. Let me, can you share? Okay, go ahead and share. That looks right. Oh, at the very top, the very first one. Huh. Thank you. He's speedy.
Thank you.
I would not have seen it. Okay, so notice your invoices 1 table has these new constraints. And looking at them doesn't really tell us a lot. You know, we would have to send them to something or whatever to keep that information. I'll show you that in just a minute. Let's create another invoices table just a little bit differently. So we want to do kind of the same type thing. Create table invoices 2. We're going to add our invoice ID as an integer. And we're going to say it's not null and is identity and a primary key. And we're going to add our invoice total and say it's money. Not null. And another one, our payment total. Money. Not null. So I still want to add those constraints though, that our invoice total and our payment total have to be positive values. So we're going to add them as table level constraints. So we're going to say check and then open parenthesis. Then within one set of parentheses, I want to check if my invoice total is greater than or equal to 0, close parenthesis. And my payment total is greater than or equal to 0. Close that parenthesis. Now I can finally close my check parenthesis, and then I should be set. So in this example, we just add the check constraint at the table level. When we get done creating this table, if we look at it in our object browser, we should see the same exact information as that previous one. We just used a little bit different syntax to do it. So let's run this one. Okay, they've got one more. I'm gonna create this last table. Invoice 3. And for invoice 3, we're gonna have invoice ID. The int not null identity primary key. Then invoice total to be money, not null check. This time we're going to say invoice total greater than 0. The only reason we're really creating this other one is just so we can make it really easy on ourselves to try some testing. Let's create it. Not sure I created my invoice 2 table, so I'm going to execute them both. Oh, yep, I did. I'll refresh. Now, if you look at your tables, invoice 1 and invoice 2 should have the same constraints on them. They just are appearing a little bit differently, right? Because this one is going to pick both of those columns. And invoice 1, we created them individually. I still don't have my invoice 3 table. Let me run that again. It's just not showing up. It's done with me.
I see it.
Do you see it?
Yep, it says invoice.
Oh, there it is. It's in the wrong place, isn't it? So I would have to drop it and recreate it. Now after my drop, I'm going to have to put a go keyword because I want that to be executed before my next command. And try to run it. See if that's better. Ah, fixed it. Now, because we have all of these different column commands whenever we're creating tables, usually everybody just drops the table and recreates it when they have some sort of change to make like that. It's just easier than trying to redo it with a
I was just going to say, when you're done, you need to go up
Sure,
Thank you.
no problem. So let's say I've been sitting here, I've been doing all this hard work and I've got all these tables created. So I think my group should just be happy as clam with me. And instead they're all upset saying, well, how am I supposed to create that in my table? Well, I'll show you. I showed the C# classes with keep showing everybody. I need to generate the definitions for my 3 new tables. So I'm gonna, well, let me select them all. I'm gonna have to do it one at a time. I'm going to go to my invoices 1 table. And I'm going to right click and choose script table as. Now, when I choose to script a table, what I'm saying is, give me the DDL, data definition language, DDL syntax, that's create table, alter table, drop table is DDL. Give me that syntax so that I can recreate this table. So the syntax that I want is create, but I could choose drop and create if I wanted. Which one do you like?
Create.
Okay, let's do create to new query editor window. Now remember I had my invoices 1 table selected. So what's going to get generated here when I run this is all of that code. So it has a few extra things because it has some system settings and things like that that we don't normally type in. And you can tell here for our check constraints, it created alter table statements for those instead of just putting them in our table definition. So it does have things just a little bit different, but it gives us all of the syntax we need to recreate this invoice. And why this is important, it's not just for you guys in your groups to be able to share things, although it is really critical for that. It's important as a database administrator because you might have this database running on one server and you might need to get this same set of tables available on another database server. So you can generate the script files with all of the definitions, run them on the server that you need to bring up, and you can get the same tables created in both places.
I'm sorry I'm saying this. I was just trying to save my example that I had. How did you do that again?
Tell them how, you guys.
I'm sorry.
No, I want you to help me. Help me. What do I do? To generate this script, yeah.
You right click on it.
Yeah, right click invoice 1, and script table as. You should go to click. Create to create.
Good job. I just wanted some other voice to say it.
You would do it right.
Yep, so you can get that syntax back. We need to do one more so that you guys are ready to work on your databases. And then we can come back. Okay, so the last thing we did was create this invoice 3 or invoice as 3. Let's try to update that table so that we can see what happens if we violate that check constraint. Insert invoices 3 values -100. So the only thing that we added to our invoice table, invoices 3, besides the identity column, was this invoices total. So we should be able to run this one insert statement and it should fail because we said our check constraint is our invoice total has to be greater than or equal or greater than 0. So there it failed. Let's take a look at that message. So the insert statement conflicted with the check constraint. The conflict occurred, blah, blah, blah. So it doesn't tell us that the check constraint says it can't be negative. Notice that the check constraint just like blasts it out of there. but it doesn't really give us a lot of information. So hopefully our DBAs and our programmers have all been working together and everybody understands how that check constraint is working.
It's basically doing something similar to a try catch.
Uh-huh. Yep, it's just say, nope, won't work, won't work. Okay, let's try a fancy one. I'm over here in my never-ending query window. I want to create another table. And this is going to be our vendors table, vendors 1. And we're going to use a really hairy check constraint in this one. First of all, we have a vendor code. R for 6, not null, and it's the primary key. Next, our vendor name.
You spelled vendor wrong.
Oh, sorry, thanks. Is varchar for 50, not null. Now, our check constraint is going to be at the table level. We're going to say check, and I've got 2 open parentheses there. We want to check to see if vendor code is like A to Z. So we're saying the first character has to be alphabetic. The second character has to be A to Z. So it also has to be alphabetic. Then we want 0 through 9. 0 through 9. We want 4 of those. So we could get really fancy with our coding system, and we could say, you know, there's alpha character, then 2 numeric, then 3 alpha, whatever it is that works right for our encoding system. So that is our vendor code constraint. First 2 characters have to be alpha. The rest of it has to be numeric. And then we're going to continue our check constraint with more things. We're going to say if you left justify or take the left 2 digits of the vendor code, they should be equal to the first 2 digits of the vendor name. Yeah, that's really clunky to type. I know those regular expression pattern matching, things like that can be really difficult to get out of your keys. Now, after we run that table, I'm going to put a go there because I think I'll just run these together. I want to do an insert statement into our vendors 1 table. And let's do some values that should fail. MC4559, Hassel, Printers, Inc. This just seems like a bad idea on so many levels. Never make a code field be the same as the first 2 characters of a business name. What if they rename their business? We would have a whole new customer, so it would work out. We would figure out a way. I'm going to execute this. And what should happen, I should create my vendors table, and then my insert should fail because this MC is not the same as the first two letters of this customer name. So we should fail. And there it is. Insert statement conflicted with check constraint. Do what? Yeah, and it's a real problem with this new system where they're letting you guys change your names, because I can never find you because your account name has your real first initial, and then everything I look at has your preferred name. So that's not going to work well, what they're doing with that. Because if I get your grade wrong, just know that's why, because it's really hard to find you, because since a lot of their stuff ends up sorting by first initial, like our SQL Server account names, since it's by username, and your first initial doesn't match what your ID is, it's really hard to find you. I'm gonna actually send the help desk an email about that, saying, I don't think this is gonna work. It's not very helpful to us. They should have your old name and then in parentheses, your preferred name, so that we could find you alphabetically in those lists, I'm afraid. But yes, that's what OTC is doing, and it doesn't work super good a lot.
I know with me, I'm okay with this because my name, I don't have a nickname.
Yeah, it doesn't matter. But having you guys sort alphabetically by first initial is just so backwards when I'm trying to find you to set anything up, you know, like TFS or anything. It's just really not what you're used to doing. So if they had it last initial, first initial, then it would match all of the other systems. But it's just funny. Okay, let's create a foreign key. I'm going to open a new query window because that one's getting kind of long. And then we'll be done. Sure, she says. I want to create a table, vendors 9. And we're just going to have a vendor ID as an int, not null, primary key. Vendor name as varchar for 50. Not null. That's the end of our table definition. Let's create an invoices 9 table to go with it. We want to make this one pretty short also. Invoice ID be the same. Vendor ID is close. We want our vendor ID. Now this is going to be our foreign key. So our vendor ID, we're going to say cannot be null, but we're going to add this special keyword, references. Now, this references constraint can also be put as a table level constraint, where we could say vendor ID references vendors 9, vendor ID. So look at the references statement. References, then the table that it references, and the key that it references on that table.
So that's saying there's a relationship between those.
That's setting up that relationship and saying that this is a foreign key to your vendors table. Okay. Let's run that one.
We need to go after we create the vendor
You might. Let's put it in to be safe. It's a good idea. Perfect. Next time, we really won't have too much more syntax to look at, a little bit of altering and dropping, but that's a lot of the creation syntax. So we'd like for next time for you guys to really work at trying different things on creating your tables, you know, because just like they've shown here, sometimes you want to use a table level syntax and sometimes you want to use a column level. So it gives you options. Questions before we go?
I would like to see invoices line again.
Sure.
I kind of can't see it. Thank you.
Sorry. Oh, it just moved on you.